This video covers rationalizing square roots. Most square roots are easy to simplify, but sometimes you get into a situation where you have a square root in the denominator of a fraction. When that happens, there's a general rule, and that is to never leave a square root in the denominator. So the process to clear this up is to simply take your numerator and your denominator by the simple square root that's in your denominator. So you'll see here two examples, 4 over the square root of 5 and square root of the square root of 12 over square root of 7. What you're going to do is multiply your top and bottom, your numerator and denominator, in this case by the square root of 5 because that's your simple square root in the denominator, and in this one it would be by the square root of 7. In this video I'm going to go through about 6 or 7 examples of various kinds where I rationalize the denominator of a fraction. I would like you to take notes on these videos, so please have your paper and pencil ready to go. In example 1, I have 3 over the square root of 6. I can't have the square root of 6 in the denominator, so what I'm going to do is take the numerator and denominator by the square root of 6. I'm going to multiply by the square root of 6. So it looks like this. Now keep in mind that the square root of 6 over the square root of 6 is 1, so you are not changing the value of your fraction. All you're doing is changing what's in the denominator. In the denominator, I'm going to start there first, I have the square root of 6 times the square root of 6. That's the square root of 36. And we're going to simplify that in a minute. In the numerator, I have 3, which is not under the radical symbol, and square root of 6, which is under the radical symbol. According to the rules of multiplication, you cannot combine these to make an 18, but you can combine them to make 3 times the square root of 6. Now I'm going to simplify. The square root of 36 is plain 6 with no radical on it. I can't simplify my numerator, so it's going to say 3 square roots of 6. I do have one final check, and that's to see if the numbers outside the radicals simplify, and 3 over 6 does simplify to 1 over 2. So I'm going to rewrite this again. I don't need to write the 1 in, so I'm going to keep the square root of 6, but 6 divided by 3 is 2, because that's a 1 over 2. My last check is to make sure that the square root of 6 doesn't simplify. There are no perfect squares in the 6, so this is my final answer. Our second example is the square root of 4 over the square root of 5. Now once again I do have that square root of 5 in the denominator, but before I start this process I'm going to see if I can simplify my problem first. So I'm going to have 2 over the square root of 5. Now I'm going to start the rationalizing process. I'm going to multiply numerator and denominator by the simple square root in the denominator, which is square root of 5. On the numerator, I have 2 times the square root of 5, and once again, you cannot take the 2 times the square root of 5 inside and get a 10. You must only multiply a radical by a radical. So what I have is 2 square roots of 5. In my denominator, I have square root of 5 times square root of 5, and that is square root of 25. But remember, the whole point here is to make that denominator into a nice number. So I'm going to simplify. I have 2 square roots of 5 over 5, because the square root of 25 is 5. I check to see if I can simplify the 2/5, and I cannot. The fraction is reduced, and there's no simplifying on the square root of 5. And so this is my final answer. Example number 3. In this example, I've added a number in the front of the radical in the numerator so I can make it a little more interesting. And I want to go through the process again. Now square root of 3 doesn't simplify, nor does the square root of 5, so I'm just going to start right away with the rationalizing process. I'm going to multiply numerator and denominator by square root of 5. Always whatever the square root is in the denominator is what you're using here. Okay, I'm going to take the 4. There's nothing in front here, so I have 4 times 1, which is 4. Square root of 3 times square root of 5. These two get multiplied together, so I have square root of 15 over the square root of 25. The square root of 25, remember, is plain old 5, not with a radical, just 5, because you've taken the square root. And I have 4 square roots of 15. Now I need to check to see if there's a perfect square in 15. Well, if I look at my perfect squares, remember those are 4, 9, 16, 25. None of these numbers will divide evenly into 15, so this will be my final answer because 4/5 does not reduce. Okay, what I would like you to do now is I would like you to pause this video and try example 4 on your own. When you get done with it, or as far as you can, please restart the video and see how it's actually done. Okay. Alright, now that you've done this problem or attempted this problem, I'm going to go through and actually solve it for you. Once again, I look at my problem. I have two options here. The square root of 12 does simplify before I actually start the rationalizing process. Sometimes it's easier to simplify before you rationalize because otherwise your numbers can get very large. If you didn't notice and you rationalized right away, then you're going to have to simplify at the end because you're going to have to make a simplified answer. I'm going to start with simplifying the square root of 12. The square root of 12 breaks to square root of 4, which is in my list over here, times the square root of 3. Because 4 times 3 is 12. I still have the square root of 7 in the denominator. The square root of 4 is plain old 2 without the radical symbol. So now I have 2 square roots of 3 over square root of 7. What I'm going to do now is the rationalizing process because I have actually finished with the simplifying. So I'm going to multiply numerator and denominator by square root of 7. That's top and bottom, numerator and denominator. And what I have is 2 square roots of 21, because 3 times 7 is 21, over the square root of 49. Now remember, the whole point is to simplify your denominator. Well, the square root of 49 is plain old 7, and I still have 2 square roots of 21 in my numerator. I check the 2/7, it doesn't reduce. The 21, I do one final check to see if I can simplify. I want to know if 4, 9, 16, 25, will any of those divide evenly into 21? None of them will, so this is my final answer. Hopefully you got something close to that when you attempted this on your own. Example 5. If you would like to stop the video, please do so and attempt example 5. If not, go ahead, continue watching. I will solve example 5. The first thing I'm going to do with example 5 is look to see if I can simplify the 15. The 15 is basically made from the square root of 3 times the square root of 5. Now neither is perfect, so I can't simplify it, but if I really think about that, if 15 is made from square root of 3 times square root of 5, and I have a square root of 3 in my denominator, the rules in fractions say that you can reduce by whatever's common in the numerator and denominator. So I'm going to reduce by that square root of 3, and so I'm left with just the square root of 5, and I no longer have a square root in my denominator. That is my final answer. So that makes that a very quick and easy problem. Example 6. Feel free to pause and attempt this one if you would like. I'm going to continue on in solving. I'm going to first start with simplifying the square root of 8 because I know there's a perfect square in there. 8 is made from the square root of 4 times the square root of 2, and I still have my denominator at square root of 7. The square root of 4 is plain 2, and I still have the square root of 2 over the square root of 7. Now I can't reduce, so I'm going to rationalize, multiplying top and bottom by square root of 7 over square root of 7. And so what I end up with is the 2 in the front. I'm going to multiply the square root of 2 times the square root of 7. I get the square root of 14 all over the square root of 49. We need to simplify that denominator. The square root of 49 is 7. so I keep my numerator at square root of 14 times 2. I check to see if I can reduce the 2/7. I can't. I check the square root of 14 to see if I can simplify. So I need to know, do any of these numbers, 4, 9, 16, 25, the perfect squares, divide evenly into 14? Well, no, they don't, so this will be my final answer. Example 7. The same here. If you would like to pause the video and attempt this one, that's fine. If not, continue listening and I will solve. Okay, I look at the square root of 15. There are no perfect squares in 15. Remember, the perfect squares are 4, 9, 16, 25. But I do know that 15 and 6 have something in common, and that is the square root of 3. So I'm going to write this out. 15 is made from the square root of 3 times the square root of 5. 6 is made from the square root of 3 times the square root of 2. The square root of 3's are going to cancel. So now I have a new problem. It's the square root of 5 over the square root of 2. And I'm going to rationalize this. Multiply top and bottom by square root of 2. And I get 5 times 2, or the square root of 10, because they're both under the radical, over square root of 4. The square root of 4 is plain 2, that's my denominator. And the square root of 10 is made from 2 and 5, so no perfect squares in there. So square root of 10 over plain 2 is my answer. One more to go. If you would like to pause, feel free to solve this problem and then come back and listen to the solution. Now this one's a little more complicated. It has an integer in front of the radical, a 3 and a 2. And then, of course, I have the radicals. At a quick glance, I can see that neither radical reduces or simplifies. There are no perfect square in them, nor do 7 and 5 have any common factors other than 1. So I'm going to go right to the process of rationalizing. Top and bottom by square root of 5. And I'm multiplying, remember. So I have 3, 7 times 5 under the radical, so square root of 35. Over 2 square roots of 25. Now 3 or 2 do not reduce down, that's not a fraction I can reduce, but 25 can simplify to 5, so my denominator now becomes 2 times 5. And I'm going to keep my 3 squares of 35 in my numerator. Now 2 times 5 is 10. So my denominator becomes 10, and I have 3 square roots of 35 in my numerator. Now I check to see if I can reduce the square root of 35, so once again I try the numbers 4, 9, 16, 25. These are the perfect squares. None of these will divide evenly into the 35, so this is simplified. 3/10 does not reduce down as a fraction, so this is my final answer. This concludes the video on rationalizing square roots. Please remember that if you need more help, go back to the beginning and watch it again, or to look back in your notes. Also, stop in and see your teacher if you need extra help.